Hello, this is Amos Tarfa, and I will be your instructor for the Algebra 1, Algebra 2, and Pre-Algebra course. In this course, as you know, we're covering topics in equations, inequalities, graphing, polynomials, systems of equations, rational expressions, quadratics, radicals, and functions. We're going to cover all those topics, but what we're doing different in our course is we're also talking about the history and the applications of the concept. Why is this important? Because we want you to leave the topic thinking to yourself, okay, why did this guy do this? Why did René Descartes do what he did? And how can I make it better? What concepts can I come up with? So we want to help students from all across America and the world to publish their work, even if they're still in middle school or high school. What have you observed and that you want to publish in a math writing, right? Let's follow in the steps of James Clerk Maxwell and publish papers early. René Descartes, before I get into graphing in detail, we're going to talk a little bit about the history. René Descartes is a French mathematician who did amazing work, and he died at the age of 54 of pneumonia, which is unfortunate, but part of it is that he was tutoring the Queen of Sweden early, 5 a.m. or so. Like, don't do math at 5 a.m., okay? Read your Bible and pray at 5 a.m. Do math later in the day. Now, maybe Descartes did that earlier in the day. He was also a person who had faith. He also professed some faith as well. It's very interesting to see the history of science, by the way, and mathematics. A lot of those people had faith along with the work they did. It wasn't like science versus faith. Their faith inspired their science, right? I'll give you one more example of one of his colleagues, which is Blaise Pascal. Blaise Pascal is known for saying a few things, and we attribute the quote that there's a God-shaped hole in everyone, right? And only God can fill that. That was a mathematician, but now he's also talking about faith. He was called a Christian apologist. So we're going to talk about graphing, we're going to talk about René Descartes, and we're going to talk about the applications of graphing, and then we're going to end with a few practice problems. One of the resources I'll be using today is a book on the history of mathematics, which I have right in front of me, but I also have this good resource about coordinate planes that talks about the work of René Descartes. So let's talk a little bit about graphing, and then we'll go back to who René Descartes was. So graphing generally deals with working with the x-y coordinate system in this sense, in this specific case, right? So you have a coordinate system. This is called the y-axis, and this is called the x-axis. Everything to the right is positive, so this is the positive section. Everything to the left is negative values, they're negative integers. In a different video, there's a discussion about different types of numbers. There is positive numbers, whole numbers. There's integers, which contain both the positive and negative numbers. So when you think of a house address sometimes, basically what you're saying when you say the avenue and the street is you're giving the coordinates. We use coordinates every day in different ways, right? Our GPS system is using coordinates, right? Details with coordinates. So we'll start with the history again. Graphing we call it the Cartesian plane. Why do we call it the Cartesian plane? Because of René Descartes. He was a mathematician and philosopher born in 1596. René Descartes was born in 1596, so keep now in reference. Let's look at the reference. A big part of what we're doing this year in our schools, at Lifestem Academy and so on, is talking about Western civilization. So let's come down here, and let's draw a line like this. In 1450, we got the printing press. In 1517, we say the Reformation and the work of Martin Luther, which allowed, again, for literacy to go higher because people are reading more, right? He's working on translating the Bible into a language people can understand, right? Then we come into 1642, the work of Isaac Newton. Between the Reformation, right, and the birth of Isaac Newton, we call something here the Copernican Revolution. So we've had the printing press, we've had the Reformation, we have people now, more people reading, and then we have the Copernican Revolution. The sun is the center of the solar system. Around 1596, we get René Descartes, right? And then between 1550 and 1650, those 100 years, you have people like Galileo Galilei, and now you have René Descartes. You also have another man by the name of Pierre de Fermat, and we'll have a video about Fermat's last theorem, which is a fascinating topic that I will encourage you to study, at least the history of it. So, where are we at in history? It's 1596, René Descartes is born. He's born in 1596, and he writes, he does work that, we call it the Cartesian plane, which has to do with the work that he has done, right? So he was born in La Haye in the French province of Tutoring in 1596. He died in Stockholm, Sweden in 1650. His father, Joachim, was a counselor in the High Court of Rennes in Brittany. His mother, Jenny, was the daughter of a lieutenant general from Poitiers and the owner of property that was eventually assured Descartes assured him of financial independence. His mother died in 1597. You will notice that some of these mathematicians lost their parents at a young age. Isaac Newton lost his dad at a young age. James Clerk Maxwell lost his mother at the age of 8. So it's interesting the adversity that some of them had to go through in order to become who they became. Some of them were sick a lot. Blaise Pascal had a season of being sick as well. He died at the age of 39, by the way. But notice that the big country in question right now is France. So René Descartes, French. Pierre de Fermat, French. Blaise Pascal, French, right? So France is producing this people of high mathematical ability. I'm sure other countries had their own things they were doing, but one of the things France was doing was giving us some of these high-level mathematicians. Here's something to keep in mind. At this point, there was no America yet as a nation, right? This great nation didn't come till later on. So a lot of the action is going on in France, in England, in Italy, in Germany, and we'll be talking a lot about all of those, okay? So Descartes comes, he gives us the Cartesian plane, right? So we get the Cartesian plane, which is used for graphing points. That's one of the main things we're going to focus on today, which is that you can plot points, right? So whenever you're learning any math concept, it's always good to isolate what are the skills I need to know. So you need to know how to plot points, right? So the first thing about plotting points is knowing that there's an x-axis and a y-axis. The x-axis here, when I write the coordinates for this specifically, I would write something like this. The x-axis is, the x-coordinate is 2, the y-coordinate is 3. So this corresponds to 1, 2, so that's what you're seeing, that's that part. And this is 1, 2, 3, so it's 2, 3. So we're plotting points, the first step with graphing. So as far as the history, we have René Descartes, we have work happening in France. This is a branch of math we call analytical geometry. Prior to this time, we have a lot of pieces of geometry going on, and these guys are now going to bring it and give us a new realm, right? So Descartes' work actually helps Isaac Newton's work in calculus, but Descartes' work also helped Albert Einstein somewhat in terms of some of the details that have to do with this basic mathematical principle of graphing. So Descartes, who lived back in the 1600s, influenced the work that happened even into the 1900s. Wouldn't it be cool to go back and read Descartes' work then, right? That's what we're trying to teach people. And that's why even if you're the best student in math in your state, in your country, I still encourage you to look at the resources we're putting out because we want to help you to be the best, not just by comparing yourself to others. Don't do that. Ask yourself, what skills have I been given? What have I been blessed with, right? We believe every student is created in the image of God with unique skill set, so we want to help you build those skills, okay? So if you have the math ability, make sure you take our Gen Math Tournament, which is in October 23rd, Gauss, Euler, Newton Math Tournament. We want everybody to enjoy the process of like speed math, work on your speed within mathematics. So that's coming up later on. But I just wanted to tell you, I encourage you to read the original works of Descartes, even if it's a little bit. Read the original works of Euclid, even if it's a very little bit. Read the original works of Euler, the original works of Newton. And it's amazing what you learn when you learn it directly from them, right? That's what we're going to encourage our students to do. So that's the history of graphing, comes from René Descartes and work in France, and now it's used in many fields. Like you cannot go through any math or science, any serious science course or any math course without doing some form of graphing. So we'll be talking more about the applications of graphing as it relates to different pieces of geometry as well as just physics and chemistry and so on. Practice. Let's end with this. In this video, I just want to introduce you to graphing and the history and the applications, but I'm going to end with one practice skill for you, and this is slopes. Sir Isaac Newton is known to be one of those behind the calculus, we call it. There's Isaac Newton, and then there's also another gentleman called Gottfried Leibniz. There's actually arguments, right? One was German and one was English. Until today, I see some tension, right? Maybe just from the YouTubers. But I've seen some tension of like, there's that, who's the father of calculus, right? I personally, I think Newton did a great job there, but I'm fine with saying Newton and Leibniz, and that's what many people would say, that they are the two people. However, apparently Newton was upset at Leibniz because he thought it took some of his ideas. Whatever the case, let's not get into a math battle about who's the father. I'm just glad that we have calculus. It's beautiful, and I train all my students to have the capacity to do it, because if you can do calculus, there's nothing you can't do. Now, here's what's interesting. With calculus, the biggest topic is slope. And the formula for slope is actually m is equal to y2 minus y1 over x2 minus x1. That's a very important formula. We're going to use it over and over again. I'll do one example, and we'll land our plane. So basically, I gave you a point. This point can be called x1, y1. If I give you another point over here called 1, 1, then this point can be called x2, y2. So you have x1, y1, and x2, y2. You bring it over to the formula. In every math problem that involves a formula, I highly recommend writing out the formula. So you write down the formula for finding the slope. Okay, so we've written the formula. And now we're going to substitute the values into the formula. So what does it mean to substitute the values? What is x2 and y2? Well, y2 is 1, y1 is 3, x2 is 1, and x1 is 2. So in math, you write the formula, you plug in the values, and now you simplify. M is equal to minus 2, like that, right? Now, if you don't know how to work with integers, this is a good time to review that. We can set that up. So you have negative 2 over negative 1, and now that answer is equal to 2 over 1, which is just 2. Okay, there's a lot to unpack here, so let's do this. There's a book by Anders Ericsson called Peak that teaches you about deliberate practice. The best way to practice math is using deliberate practice. One of the principles of deliberate practice is finding any gaps you have and filling in those gaps. If you do that, you will get far ahead in math. They use this principle in a physics class where they use deliberate practice in one classroom with people that were not yet professors, and in the other classroom they had a traditional approach with professors. The people in the deliberate practice class covered more material and performed better on assessments than those in the other class. Imagine if you could finish your whole math book in half the year. Right? Some kids are like, oh, that sounds good, then I can play. Nope, in Amos's world, that means you just get into the next math class, right? My goal is to get you to love the math, love the process, love the journey, understand the people. Math is a skill that will not just help you within the scope of what you're learning, but it will teach you how to think better. Math will teach you how to think better and consistently. There's a lot more to say, but let's land the plane with this. The reason why this is negative 2 of negative 1 here, of course, was we did the math. The negatives canceled. We got 2 over 1. We wrote it as 2. Please show your work as you work through any of the modules or problems. Send me an email at amostarfa1@gmail.com if you ever have questions. Thank you for your time, and have a blessed day.